Hi, this is the video on Introduction to Organic Chemistry, Pure Chem, Chapter 21, Science Chem or Combined Chem, Chapter 18, and Normal Acad Chemistry, Chapter 14. So let's look at the learning objective. Define a homologous series. Now, organic compound. Now, in NTUC, there is a section that is selling organic vegetable. So basically, organic vegetable means that the vegetable is grown using natural using natural fertilizer like cow dungs, chicken dungs, etc. There is no pesticide. Okay, that is in the vegetable. In the NTUC, the organic vegetable. But for chemistry, the term organic is slightly different. So organic compound basically means that it must contain carbon. There must be this element called carbon in the organic compound. But not all carbon containing compounds are organic compounds. So for example, carbon dioxide. There is carbon in carbon dioxide, but carbon dioxide is not an organic compound. Likewise for carbon monoxide, likewise for XCO3. That means this X can be like calcium, magnesium, like calcium carbonate. So XCO3 basically it's all the metal carbonates. They are not organic compounds. So while all organic compounds contain carbon, but not all carbon-containing compounds are organic compounds. So these are the three exceptions of compounds that has carbon, but they are not organic compounds. Now, organic compounds commonly contains oxygen, hydrogen, and nitrogen. And for compounds that contain carbon and hydrogen only, these compounds are called hydrocarbon. And hydrocarbon is an organic compound. So hydrocarbon from the term hydrocarbon, it means contains hydrogen and carbon only. So for example, CH4, which is methane. So methane is an example of hydrocarbon, and methane is an organic compound. Alright, so from this section, you just need to know that organic compound must contain carbon, but not all carbon-containing compounds are organic compound. And also hydrocarbon means that the compound must contain hydrogen and carbon only. An example would be CH4, methane. Now, classification of organic compound. There are many types of organic compound. Okay, first thing you need to know the term homologous series. So homologous series basically means families of organic compounds with similar chemical properties. And compounds of the same homologous series contain the same functional group. So there are two terms here, homologous series and then functional group. So all the homologous series or each homologous series must have the same functional group. And functional group are atom or groups of atoms shared by all members in a homologous series, and it gives the homologous series its chemical properties. Now, the concept of homologous series is very similar to human. So, for example, organic compound, okay, there are many types of organic compound. So each type of organic compound is called a homologous series. So for example, you have 3 homologous series, and each of these homologous series must have a functional group. And this functional group basically gives the homologous series its chemical properties. Now this is very similar to human. Okay, human, you have many races. You have maybe race 1, race 2, race 3, and each race there is a distinct culture. you have culture 1, culture 2, and culture 3. Okay, so this is very similar. So organic compound, very similar to human. Each organic, there are many types of organic compound. So each organic compound or each families of organic compound is called a homologous series. Just like human, you have many races. Okay, each race there is a distinct culture. Each homologous series there is a group, there is an atom or groups of atom that is specific to this homologous series. All right. So now we look at what are the homologous series, what are the types or what are the families of organic compound. So these are the families of organic compound. Alkanes, so this alkane is a homologous series. It's a homologous series of organic compound. Okay, we have alkenes as well. We have alcohols, we have carboxylic acid. All these things you will study in the subsequent chapter. Chapter 22, 23, 24. This is for the pure chem. Okay, for combined chem, you will also study, just that the chapter numbers are different. So, alkanes, what is the homologous series? I mean, the alkane is the name of the homologous series, and each homologous series there is a functional group. Alkane actually doesn't have. Alkenes, there is a functional group, carbon-carbon double bond. That means that all the alkenes must have this carbon-carbon double bond. Just like, okay, so all the alkene must have the carbon-carbon double bond. Just like, for example, all the, let's say the Chinese, the ethnic attire would be the cheongsam, for example. Okay, or all the Malays, the ethnic attire would be the sarong. Okay, so this is the functional group. Alright, so this part you must memorize the definition of homologous series, which is basically here, as well as the functional group, which is basically here. So this one is the definition, the key terms. Okay, the next part would be on naming the homologous series. Now the naming of organic compound. Now the name of organic compound is a bit complicated. So in general, it can be broken down into two parts. The first part is called the prefix. Okay, the first part of the name, just like the Chinese name, you have the surname and then followed by the first name. Like for example, Tan A Cao. So Tan would be the prefix, the surname, and then A Cao would be the suffix or the first name. So the first part of the name of organic compound is determined by the number of carbon atom. So the first part of the name of an organic compound, you have to look at how many carbon atoms are there in the organic compound. If it is one carbon atom, then the first part of the name is meth. 2 carbon atom eth, 3 carbon atom prop, 4 carbon atom but. Okay, and then the second part of the name would depends on what is the family of the organic compound. Which family is it in? If it is alkane, for example, if it is alkane, then the second part of the name will be ANE. If it is alkene, there will be ENE, etc. Now let's look at the example. So this is an organic compound. Okay, you can this is the structural formula. You can actually write down the molecular formula. The molecular formula would be C3H6. C3H6 would be the molecular formula. The structural formula would be like this. The structural formula shows all the bonds between the atoms. So let's name this organic compound. First part, you have to count the number of carbon atoms. How many carbon atoms are there? 3 carbon atoms. So the first part of the name, 3 carbon atom, it is prop. That's why the first part of the name, the prefix is prop. The second part of the name depends on the homologous series. So over here you can see a carbon-carbon double bond. Carbon-carbon double bond is the functional group for alkene. So the name of the homologous series is alkene, and alkene, if it is alkene, the suffix, the second part of the name must have ENE. That is why propene. Let's look at this example. How many carbon atoms? 2 carbon atoms, so it is F. It has an OH. OH is the functional group for alcohol. And if the homologous series is alcohol, it must end with OL. The suffix must be OL. So it is actually ethyl. Ethyl doesn't sound nice, so the chemist decided to add an A and an N in between. So it becomes ethanol instead of ethyl. Okay, so this is ethanol, this is propene. So basically this is how you name the organic compound. 2 parts of the name, prefix and the suffix. Prefix depends on the number of carbon atoms, suffix depends on the homologous series. So for this part of the chapter, you need to know the definition of homologous series, the definition of functional group, how to name organic compound, as well as the different types of homologous series, which you'll be studying in the subsequent chapter. Okay, the second part, the part 2 of this chapter. Okay, let's look at the learning objective first. So we look at petroleum, the natural gas, as well as separating the petroleum into its different fractions by using fractional distillation. So we need to look at how fractional distillation is being done to the petroleum, and also we need to name the petroleum fractions and state their uses. Now, a lot of the organic compounds is made from petroleum or the crude oil. So petroleum or crude oil is basically a mixture. There are many different substances in the petroleum or crude oil. So petroleum or crude oil is a mixture of hydrocarbons, mainly long chain alkanes. Now, what do you mean by long chain alkanes? Long chain basically means there are many carbon atoms. Okay, there are many carbon atoms joined together. So this would be an example of long chain alkane. Okay, so all these are hydrogen, many carbon atom, long chain. Okay, long chain alkane. So it is a mixture of long chain alkanes that is basically made up of petroleum and crude oil. Now, how is petroleum and crude oil being formed? So it is formed over millions of years ago, where dead plants and animals die, they sink to the seabed, they are covered by mud and sand. So over the years, there are more mud and sand covering the dead plants and animals. So that would exert a lot of heat and pressure on it. And over millions of years later, the dead plants and animals would decompose and become petroleum and natural gas. So that is why petroleum and natural gas, usually it is found deep under the seabed or deep underground, whereby the pressure and the heat is tremendous. And natural gas usually is found above or in the air pocket above the petroleum. Okay, so this is the oil rig. So they drill under the seabed, drill to the seabed, and then get the petroleum and the natural gas up. Okay, so just I mentioned that petroleum is actually a mixture of hydrocarbons. So in order to all these are different. So there are many different hydrocarbons in the petroleum. So in order to separate them, we need to use this separation process called fractional distillation. So this is basically how it works, fractional distillation. First thing, petroleum is heated. So petroleum, it is in liquid form. It is heated in a furnace. So when it is heated, the petroleum, it will become petroleum vapor. It will enter this fractionating column. Okay, so the smaller hydrocarbons, so over here is the description. The smaller hydrocarbons basically is lighter, so they will have lower boiling point, so they will rise to the top of the fractionating column. and get collected in gaseous form. And the bigger hydrocarbons, so some of them, they have very, very long chain of carbons. So they are very heavy, so they will have lower boiling point. Okay, so they'll get collected at the lower section of the column in liquid and solid form. So in general, you have petroleum gas at the top, followed by petrol, naphtha, kerosene. So all these are the different fractions. They are the different fractions of the petroleum or the crude oil. So you have gas, liquid, 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 solid. All right. So you have gas to solid. So this is the separation process of in the fractionating column, fractional distillation. So this part which shows the different uses of the different fractions of the petroleum. So for example, petroleum gas, what is it used for? It is used for cooking and heating. So over here you can see that the number of carbon atoms per molecule is very little, 1 to 4. So one of the example of petroleum gas would be methane, because methane has chemical formula for methane is CH4, 1 carbon atom. So methane, it is used for cooking and heating. Then after that, petrol or the gasoline, 5 to 10 carbon atoms. It is for car engine. And then as you go down, the number of carbon atom increases. So boiling point number of carbon atom increases, boiling point increases as well. Okay. So I circle this naphtha. Okay, be careful of the spelling. Naphtha, it is basically used as feedstock or raw material for the petrochemical industry. So petrochemical industry, basically the industry that make plastic, detergent, etc. This is very important, naphtha. Alright, let's look at the learning objective. Describe petroleum as a mixture of hydrocarbons, natural gas, petroleum, how is it being formed. Describe the fractional distillation of petroleum. So this one would be the description. Okay, how it works, fractional distillation of petroleum, as well as naming the petroleum fractions and stating their uses. So this table is very important. So you need to remember the different fractions from lower boiling point to the high boiling point. There are 7 fractions, as well as their uses. Okay, the third learning objective is on describing the issues related to the competing uses of petroleum. So petroleum, as of now, 90% is used as fuel. Okay, vehicle fuel, generate electricity, etc. And only 10% is used for petrochemical feedstock, manufacture plastic, detergent, etc. Okay, this is not a ideal scenario, because the ideal scenario should be 90% here, maybe 10% here. So over here, 90% is used as fuel. This is not very desirable. Okay, that is why we are, all the governments, they have been encouraging use of public transport in order to cut down on the usage of petroleum for vehicle fuel. So petroleum is a non-renewable resource. So if we continue this trend, right, 90% of the petroleum being used as fuel, so sooner or later we'll run out of petroleum pretty fast. Okay, it will run out one day, so we need to conserve it so that it will last longer. How do we conserve it? There are many different ways. Reduce use of petroleum, like I mentioned, reduce the number of cars, encourage the use of public transport, use fuel efficient car, for example, hybrid car. Then of course another way would be using alternative energy. What do you mean by alternative energy sources? Like for example, solar energy, nuclear energy, wind energy, and other alternative fuels like biogas and biodiesel. Okay, what do you mean by biogas and biodiesel? The description is here, so you can take a look. And also of course improve the design of a power station so that using less amount of petroleum will be able to generate more electricity. Alright, so that's basically sum up the this chapter, Introduction to Organic Chemistry. Thank you for watching. Bye bye.